Alright, so today we are looking at building the unit circle. And what we mean by unit circle is that the radius of the circle is equal to 1 unit. That unit could be 1 foot, 1 meter, 1 inch, 1 yard, 1 kilometer, be really big, but the radius is 1. So what I want to do here is I want to start with this very first angle. So I'm going to come in here and trace this guy with my orange. And actually, before I get into that, I want to talk about some of the ordered pairs that we know. If this is a unit circle and the radius is 1, this point right here would have the ordered pair 1 for x and 0 for y, because this portion right here is the radius of the circle, right? And then this point here would have the ordered pair 0, 1, because this line segment would be the radius of the circle also. And then the ordered pair that's on this point would be -1, 0, because if this is the radius of the circle, this has a length of 1, but it's going to be negative. And then the point on the bottom of the y-axis would be at 0, -1, because again, that's also the radius of the circle, but it's in the negative direction. So we know those 4 ordered pairs. And ultimately, what we're going to want to do is we're going to want to find the other 12 ordered pairs around this circle. But we're going to do them like in little families based on reference angles. So first, we've got this angle right here. This angle measures 30 degrees. Okay? We could take our protractors and verify it, but that's not really why I gave you the protractor. I gave you the protractor just to have a straight edge. That's a 30-degree angle. And I want to find this ordered pair right here. And so the way I'm going to do that is I'm going to create a right triangle. So take your protractor, and remember that a right angle happens when you have 2 lines that are perpendicular. So if we drop this straight down, we will form a 90-degree angle. So now what type of a triangle do I have? A 30, 60, 90, right? So on my sides, I have a short leg, a long leg, because it's going to be across from the 60 degrees, and a hypotenuse, right? Which one do I already know the measurement of? The hypotenuse. How long is the hypotenuse? 1. Why? It's the radius of the circle. Everybody see that? So the hypotenuse is 1. Alright, so 30, 60, 90 triangles. If you know the hypotenuse, how do you get to the short leg? Divide it by 2. So wouldn't this short leg be 1/2? And then if you know the short leg, how do you get to the long leg? You multiply by the square root of 3. So without, I don't want to put too much on this and make it too crowded, but I'm going to take the short leg, 1/2, and I'm going to times it by the square root of 3. So remember, if you multiply fractions, you just multiply across, numerator times numerator, square root of 3, denominator times denominator, 2 times 1. That'd be square root of 3 over 2. Everybody sees where that came from? So this distance is square root of 3 over 2. Does that make sense to everybody? All right. Now, we're going to be seeing these numbers quite a bit, so I want us to have a feel for their value. So 1/2 is what in decimal? This is 0.5, right? But what about square root of 3 over 2? Take your calculator. Let's do the square root of 3 and then divide it by 2. See that it's about 0.87? So, does that make sense? 0.5 for a short leg, 0.87 for a longer leg, and then 1 whole for the hypotenuse, because the hypotenuse is the longest side. Does that all make sense? And some of you are like, yeah, Ms. Collier, special right triangle. We did that like 2 weeks ago. Okay, so now, if that's my special right triangle measurements, here's the connection. This point right here, what's the ordered pair? Your ordered pair is your xy value, right? So look at this point. It's this far on the x-axis, square root of 3 over 2, and this far up on the y-axis, 1/2. X, Y, ordered pair. All right. Talk this out with your partner. Tell them, partner 1, how did we get the 1/2? Partner 2, how did we get the square root of 3 over 2? Talk to each other. All right, attention, let's come back together. All right, so now, if you understand this really well, this 30-degree angle that's in the first quadrant, we're now going to go around to the second, third, fourth quadrant, but you're going to see how this is related, and we're going to start to go faster with each one. So, let's come in with our colored pencil and trace this angle here. Now, what I'm talking about is this angle that measures a certain degree. But how many degrees is inside right there? That's 30, right? You can see it? Isn't that just this triangle reflected over the y-axis? So that's 30 degrees. Well then, how much is this angle? This much has to add up to what? 180. So 180 subtract 30. So this is a 150-degree angle out to here, right? But the reference angle for 150 degrees is going to be 30 degrees. So you take your protractor and drop a perpendicular. Do you see that we also will have a 30, 60, 90 triangle, right? The hypotenuse is the radius of the circle, which is 1. So what's the length of my short leg? Half. And then what's the length, just the length on the triangle of this long leg? Square root of 3 over 2, right? These two triangles are congruent. Remember CP, CTC, corresponding parts of congruent triangles are congruent. They're 30, 60, 90 triangles. The radius is both 1. So we could go side, angle, side. They're congruent. So these other parts have to be congruent also. Alright, so then that comes up to this dot right here. What's the ordered pair going to be? Ordered pair XY. What's the sign of the x value? So it's going to be negative square root of 3 over 2 and positive 1/2. Compare that to our other ordered pair. The absolute value of these numbers is the same. The sign of the x value is different because we're in the second quadrant. All makes sense? Alright. Well, now let's look at this guy right here. Isn't this angle also 30 degrees? So I could form a right triangle here as well. This radius is 1. Well, I already know the length of this side. Right? Remember the reflexive property? A line segment is equal to itself. So if it was the square root of 3 over 2 in this triangle, this is still the square root of 3 over 2. And this side over here has to be 1/2. So what's my ordered pair now? X is positive or negative? Negative square root of 3 over 2. And Y is negative 1/2. And how many degrees is this angle? (180 plus 30, right? So we've got a 30 degree angle, a 150 degree angle, a 210 degree angle. They all have a reference angle of 30 degrees. The ordered pairs are all related, right? Only the signs are different according to what quadrant you're in. Alright, we got one more to go, this guy right here. Same thing, if I drop a perpendicular, I am forming a 30, 60, 90 triangle. It's congruent to this triangle. Radius of the circle is 1 because it's a unit circle. Short leg is going to be 1/2. So what I'm interested in is what's the ordered pair? Square root of 3 over 2, negative 1/2. Negative because I'm down in the fourth quadrant. Right? So let's go back. What angle is this? It's the angle that starts here, right, and goes all the way around to here. It almost goes to 360. It's just 30 degrees short of 360, so it must be 330. Alright, so there's a lot of angles going around there. You may want to put a little list here. We have a 30 degree angle, 150 degrees, then we have 210, and then we have 330. All of these go back to the reference angle of 30 degrees. X value is always going to be square root of 3 over 2 or negative square root of 3 over 2. Y value will be 1/2 or negative 1/2. So now we're going to look at a purple unit circle, right? So this is still a unit circle. Okay, but now we want to focus on this angle. This is a 60-degree angle. All right, well, we're going to do the same thing. We're going to take our protractor and we're going to draw a perpendicular line segment. Perpendicular lines form a 90-degree angle. So if I've got 90 and 60, this angle must be 30, right? So again, I have a 30, 60, 90 triangle, but it's oriented different than my other 30, 60, 90, right? But how much is the hypotenuse? It's still 1 because it is still the radius of the unit circle. But look at where your short leg is. I mean, actually, just look at the side lengths. I have this measurement here versus this measurement. I can see this is the shortest. I also know it's the shortest because it's across from the 30 degrees. And so the short angle is half the hypotenuse, so it's 1/2, right? And so then my long leg is square root of 3 over 2. So then the ordered pair at 60 degrees is x, 1/2, y, square root of 3 over 2. Alright, so now let's just make our way around the unit circle. So I want a reference angle of 60 here, right? So that's going to be this ray. Drop my perpendicular. So if this is 60, and remember that a half circle is 180, so then what angle are we talking about? If we measure again from the initial ray over to here, what's this angle measurement? 180 minus 60 is 120 degrees, right? Well, again, same thing. My radius is 1. My short leg is 1/2. My long leg is square root of 3 over 2. So what's this ordered pair? X, Y. The X, is it positive or negative? Negative. And the Y is positive. Do you see now why I made you practice your signs and your quadrants? Pieces coming together. Alright, so if it helps you, you might want to put out here, this is 60 degrees, this guy is 120 degrees. Might help to put the degrees out there. Because in a central angle, which these are, the angle measurements and the arc measurements are the same, so this 60 degrees is also measuring that arc length. Alright, so now let's go down in quadrant 3. You see that the 60-degree reference angle is here. Oops, that didn't come out too good. So again, we have a 30, 60, 90 triangle. The radius of the circle is the hypotenuse, so that's 1. My short leg, I already have it, is a half. My long leg is a measurement, square root of 3 over 2. You understand, when I put it on the triangle, I'm putting all the numbers as positives because they're measurements on a triangle. But when I go to do the ordered pair, that's when the signs come in from the coordinate plane. So I'm at negative 1/2 for my x value and negative square root of 3 over 2 for my y value. So every number in the third quadrant is negative and negative. And then how many degrees is this angle? Right? It's 180 plus 60 more. So that's a 240-degree angle, right? All right, you finish off the one in the fourth quadrant. How would you do it? All right, for your ordered pairs, you should have positive 1/2 for the x, negative square root of 3 over 2 for the y, and then how many degrees around is this? It's 300, right? Because it's 360 less this 60-degree angle. So this is at 300 degrees.